at three sort of different types of Fourier series. There's going to be a Fourier sine series, Fourier cosine series from 0 to L. These are the things that we've already looked at. And then there's going to be the Fourier cosine and sine series from minus L to L. And this is going to be kind of the new thing, or one of the new things. Okay, so let me just give these definitions. So the Fourier FSS, so that's Fourier sine series. Oh, my computer's doing something weird right now. The Fourier sine series on 0 to L is, we have some given function f of x, and we associate to it a series, the sum k equals 1 to infinity bk sine k pi over L x. Okay, so what does the wiggle here mean? The tilde here means that we need to be careful about what we're saying, what the association between these two things are. What does it mean when I associate to a function its Fourier sine series? Okay, do I mean that if I plug in x here and I plug in x here, I get the same thing? Do I mean if for most x's I'm going to get the same thing, or something else? And here the coefficients bk are given by 2 over L times the integral 0 to L f of y sine k pi over L y dy. Okay, now we've only looked at these things like this when L was equal to 0 was equal to 1 or pi or something like that. But it's a good exercise for yourself to say if f of x is equal to this, then bk has to be given by this formula here, using orthogonality. That would be a good exercise to really make sure you understand the role of orthogonality in this. Alright, so f of y, so there's not, I don't know why I said f of y, the Fourier cosine series, so FCS, the Fourier cosine series on the interval 0 to L is f of x, and again with the tilde, and now we're going to look at 1/2 a0, so remember the cosine series has a constant term, so this is going to be k equals 1 to infinity ak cosine k pi over L x, and here the ak's are given by ak is equal to 2 over L times integral from 0 to L f of y cosine k pi over L y dy. Okay, and again, same issues here. What does it mean when these two things are equal to each other? And also I think it would be instructive if you, again, use orthogonality to show that if f of x is equal to a series like this, then these are the formulas for the coefficients. And again, use orthogonality. Okay, and finally, there is the Fourier sine and cosine series, or the full Fourier series. So the full Fourier series on the interval minus L to L, well, we're basically just going to add these two things together. This is f of x. Again, with the tilde, we'll do the cosine series, or the 1/2 a naught, and then plus the sum, k equals 1 to infinity, ak cosine k pi over L x plus bk sine k pi over L x. With the coefficients defined similarly to what we have over here. In particular, ak is equal to 1 over L times the integral from minus L to L f of y cosine k pi over L y dy, and bk is equal to 1 over L times the integral minus L to L f of y sine k pi l over y dy. Okay, now we haven't looked at orthogonality on the interval from minus L to L, but again, I want you to go through and use orthogonality to show that if we can write f as a function like this, then these are going to be the formulas for the coefficients for the ak and bk. Okay, again, if we can write f of x like this, use orthogonality to show that we can write the coefficients ak and bk like this. Okay, so in the next few examples, that'll be the next video, we're going to look at the Fourier sine and cosine series, and how, in what sense we can write a function as a series of sine and cosines, and also over here as well with the full Fourier series. And what's going to turn out to be very important is the odd periodic extension and the even periodic extension of a function f is going to let us know how, given the graph of a function, how we can sketch its Fourier sine series, its Fourier cosine series, and its full series. So I'm going to tell you a little bit about what periodic extensions mean, what the odd extension is, what the even extension is, but maybe look that up before you watch the next video, just so you sort of know. I don't know why I'm saying that for this one particular topic, but there, you can do it.